So welcome to part 3 of this tutorial series in Python. During this you'll learn about ranges, you'll learn about loops, and you'll learn about formatting. So here's what we're going to cover during this tutorial. You'll learn about while loops, you'll learn about how to exit while loops prematurely using the break and the continue statements. We'll look at formatting printed output, both text and also integers and floating point numbers. Then we'll take a bit of a digression and look at probably the most important concept in Python coding, which is iterators and for loops. Then we'll look at ranges or sequences of numbers, and then we'll do a practical example on nesting ranges, listing out the first n prime numbers. At the top right of your screen, a link has just appeared, and you'll be able to click on that at any time to see not only files to do with the tutorial, but also to do some exercises so you can practice and see if you've understood what you've learned. But I think that's enough of me, so I'm going to vanish now, and let's get started. Life is full of while loops, and you may be more of a programmer already than you think you are. For example, while it's raining, you'll carry an umbrella. While your cat's purring, I hope you'll keep stroking it. And while this tutorial is interesting, I hope you'll keep watching it. So let's see how this works in Python terms. The syntax of a while loop is you continue doing something while a condition is true. And for as long as that condition remains true, you keep executing all the statements which are indented after it. When the condition is no longer true, you carry on with the rest of the program. So let's see how this relates to Python. So what we're going to do to begin with is to create a program to list out the first few even squares. So I'll create a new file and we'll call it list even squares. And don't forget the .py to state to Visual Studio Code that it's a Python file. I'm going to create an integer variable and I'll set it equal to 1 to begin with. I is quite a common thing to call your loop counters. And then we're going to keep looping until we reach a certain value. And to do that, I can put a while statement, and then the condition which has to be true is I has to be less than or equal to, let's say 100. And then I need to put a colon to say that's the end of my while loop. When I press return, I come to the statements which are executed while that condition remains true. To make it easier to write, I'm going to create a variable called square and set that equal to I times itself. And then I'm going to print out a message saying the square of 2 is 4, etc. So to do this, I can put the square of, and then I need to concatenate that together with something using the plus symbol. The next thing I'm going to do is put in the integer variable holding the integer, but I need to convert it to a string using the str function. I can then put is, and finally with another plus symbol at the end, I can put the string representation of the results, the square. I think what I'll finally do, just at the end, is print out a message back indented to the left margin saying that's it. And that way I'll know when my program is finished. And I think that's it, isn't it? I think nothing wrong with that. So what I can now do is to run my program, but just before I do that, you might like to think what I've done wrong. Okay, so let's run my program. So if I press Alt-Control-N, and you can see it's printing out the square of 1 is 1, millions and millions and millions of times. So I'm going to try to abort my program, and apparently I can do that by pressing Alt-Control-M in Code Runner. And that looks like it's stopped the program running, but then it just carries on again. You can press Control-C, some people say, but that doesn't actually seem to work either. And in fact, the only way seems to be to close down Visual Studio Code and to start it up again. So that's what I'm going to do now, and I'll see you after doing that. So the thing I did wrong was that my condition remained true permanently. I will always be less than 100, less than or equal to 100, because it never actually changes. So what I need to do within my while condition is I need to increment its value. Increment is a techie programmer term for just adding 1 to a variable. So to do this, I'll show you 2 different ways to do it. The first way is to take the value of I and set it equal to what it used to be, plus 1 more. And the second way to do it is to say I plus equals 1. They both do exactly the same thing. The second way is probably the neater way to do it. There's certainly less characters. And you can also type I minus equals 1, I divide equals 1, and I star equals 1 to do similar things. So let's try running this. I'm more confident now that it's actually going to work. So if I try running it, and you'll see it's almost perfect. The only thing is I'm printing out the squares of the first odd numbers. And the reason for that is I should have started on 2, not 1. So I'll just change that and try again. And this time it's working. It's printing out the squares of the first even numbers. And that's almost the end of the story on while loops. There's one more thing you can do, which is you can add an else condition. And the else condition is used when there's something you want to print out if the loop never executes. So what I'm going to do is add a message saying it never executes and try running it. Now, at the moment, that statement will never appear because the loop does execute. So I'm going to cheat a bit. I'm going to set this to 200 rather than just 2. And if I now try running my program, and what you'll see is because the condition is never true at all, because I is never less than or equal to 100, what it will do is go to the else part of my while clause and print out the message that it never executes. And then, whether the loop executes or not, I'll get the final message saying that's it. And that's a basic loop statement in Python. What I'd like to do now is briefly look at how you can exit out of loops prematurely, or even say you want to ignore the current loop and go on to the next iteration around it. So to do this, I will create a new program, and I'll call it FizzBuzz. And if you never played the childhood game where you had to say fizz when a number was divisible by 3 and buzz when it was divisible by 5, oh, you missed a treat. So what I'm going to do is print out all the numbers divisible by 3. To do this, I'm going to start by creating another variable. I'll call this one counter for a change, and I'll set it to 0. And then I'll keep looping while things are true. Now that's always going to be true. So unless I prematurely exit out of this loop, I've got problems. It will loop infinitely. What I'm going to do firstly is to increment counter by 1 each time around the loop. Then what I'll do is test whether I've gone too far. And my definition of going too far is when I've reached 100. So if counter is greater than or equal to 100, I know I need to stop. And to exit a loop prematurely like this, you put the word break. And what that will mean is it will drop out the bottom of the loop and carry on with the rest of the statements. So the next thing I'll do is test whether it's divisible by 3. To do that, I can say if the counter, and then I'm going to use the percent operator. And what that does is divide one number by another and looks for the remainder. And if the remainder is 0, if the remainder isn't 0, so I'm going to put exclamation mark equals. So if the remainder isn't 0, then I know I've got a number which isn't divisible by 3, and I don't want to process it any further. So what I can do is use the continue statement, and what that will do is carry on with the next iteration around the loop, aborting this current one. So if I get to this point, I know I've got a variable called counter, which is divisible by 3. And so what I can do is print out the value of it. And I'm going to print out two things, the value of the variable and then the word fizz, which I believe is what you had to say when a number was divisible by 3. And finally, just to show when my loop has finally finished, I'm going to print out a statement saying that's it. So let's see what happens when we run this program. What I should see is all the numbers divisible by 3, word fizz after them, and when it reaches 100 it stops, falls out the bottom of the loop and executes the final statement saying that's it. So those are the two statements you need to know about when you're executing a loop and you want to prematurely end it or prematurely go on to the next item. Break will exit the loop automatically and you'll drop out and execute the next statement following it. Whereas for the continue keyword, it won't exit the loop, but what it will do is go on to the next iteration of it. So it will ignore any subsequent statements and go back up to the while condition at the top of the loop, and it will start again with the next iteration around it. So I think it's past time that you met our cats, and they are Annie, who's a minx, and Neo, who likes nothing better than to lie with his paw over your arm like that. So what we're going to do is to write a program to say hello Annie and Neo. But I'm going to make the program variables so that you can greet your pets instead. You'll see what I mean. So what we're going to do is to close down any files we may have open. You can do that by right-clicking on any of the tabs and choose Close All. And what I'll do is create a new program, and I'll call it Greet Pets. Forget the PY. So I'm going to create two variables called pet1 and pet2. And you can at this point set them to be the names of your pets. Obviously this program only works if you're lucky enough to have two pets. And what we're going to do is print the message saying hello Annie and Neo in three different ways. So let's start with the hard way. The hard way is to build up a message using a plus symbol to concatenate the various parts of it together. And we've seen this several times already. So I could say print. I'm going to put the word hard way at the beginning just to say what I'm doing. And I can put in hello, put a plus symbol in, put the name of the first pet, which is pet1, put in the name of the second pet, like so. And it's a real pain getting the pluses in and the spaces in, the quotation marks in, but when I run it, it should actually give me hello Annie and Neo. So the second way I'm going to do it, I'm going to call the easier way. And what this will do, let's just start it off, easier way, is we can put in placeholders for where we want the pet's names to drop in. So the first placeholder I'm going to put in is 1 for the first pet, and the second placeholder I'm going to put in is 2 for the second. And placeholders have to go in curly brackets like that. Having done that, when I finish my string, I need to put a dot in to format the string. Choose the format function. And the rules are that for however many placeholders I've just created, I need to put that many arguments. So this time I put 2 placeholders in, so I need to put 2 arguments. The first one will be the name of the first pet, and the second one will be the name of the second. And in theory, what should happen when I run this is it should take the name of the first pet, which is Annie, and display it there instead of the placeholder, and take the name of the second pet, which is Neo, and position that where the second placeholder is. But I've made one deliberate mistake, so it's actually not going to work. And if I try running it, I'll get this message. So this is why programmers get paid so much. Replacement index 2 out of range for positional args tuple. What could be clearer? What this is actually saying is that I've created 3 placeholders, because by default everything in Python starts from 0, so this is actually the second placeholder and this is the third, and yet I've only provided 2 arguments, and that's what it's complaining about. It's saying, what about the value for the third placeholder, which is this one? So there's a couple of ways around this. I could just add in a third argument. So if I did this, what it would do is put an empty string in for the first non-existent placeholder. I haven't used a 0. Put the Annie's name in for the second and Neo's name in for the third. So if I run this file or this program, you can see it says hello Annie and Neo. Probably a neater way to do it though would be to follow the Python programming conventions and put 0 in for my first argument and then put 1 in for my second. And if I try running this, you should see it gives me the same results again. So the third way to do it, which I'm going to call the easiest way, even though it's not the way I'll probably use in most of this tutorial, is to print out a message with the F prefix. And what the F prefix allows me to do is to insert variables within my string of text in the curly brackets. So I can put pet1 in there and it will automatically put that in the string of text. And I can put the second variable pet2 to display that. Now, it may look like that's the easiest way, and it probably is, but the problem is it only works really well with text. With numbers, it's not quite so flexible. And because I try to avoid showing 2 different ways to do everything, believe it or not, we're going to stick to using the format function for most of this series of tutorials. But let's just see the third way working. If I now run that program, you'll see I get hello Annie and Neo a third time. So what we're now going to do is to look at formatting numbers. We'll do 2 things. The first thing we'll do is print out the first 10 cubes. And in doing so, we will allocate 2 characters for the number which you're cubing. And for the cube itself, we'll allocate 4 characters. For the second thing we do, we're going to go on to look at printing out reciprocals. Same principle. For the first number, we'll allocate 2 digits, or 2 characters. And for the reciprocal, which is basically 1 over the number, it's a posh way of saying that, we'll allocate 1 character before the decimal place and 2 decimal places after that. Now the syntax for doing each of these 2 things is as follows. For the integer, the bit before the decimal place is the placeholder, so that'll be the first item in the list of variables to be displayed, or the list of expressions. And the bit after the decimal place is the number of digits or characters assigned to it, so that's for integers. For decimal places, it's a similar idea. So again, you have the placeholder, or position number, before the colon. And after this colon, we have the number of characters and the number of decimal points or decimal places to be displayed. And the F there is saying what sort of a number it is. It's saying it's a floating point number. So let's see how this works in Visual Studio Code. I'm going to create a new file. Let's call it listMathTerms.py. And within this, we're going to set another variable. I'll call it I to hold the loop counter. And while I is less than or equal to 10, this all seems very familiar, doesn't it? I'm going to print out both a number and its cube. To do that, I can put print, and I can put the cube of, and I can put my first expression. So I need a placeholder of 0, and then I can put is, and then put my second placeholder 1. I then need to put the format function after the string to say what I'm substituting in for each of these 2 placeholders. For the first one, I'm just putting the number itself, and for the second one, I'm putting the number raised to the power of 3. And to raise a number to the power of something in Python, you put star star, so I can put it like that. Now I'm not going to make the mistake I made last time. I'm going to make sure I increment my loop counter, so I can put I plus equals 1, which will make sure that I don't get an infinite loop. Let's try running that. If I press Alt-Control-N, as usual, you can see I get the cube of each number and its cube. Now I promised I would format them to occupy a certain number of places or characters. So to do that, for the first placeholder, I can put a colon after it, and then I can put 2 to say I want that to occupy 2 spaces. And for the second placeholder, I can put a colon and put 4 to say I want it to occupy 4 spaces. It's that simple. If I now run the program again, you'll see I get arguably a better formatted output string. So that's how you can format integers. What I'm now going to do is to comment out all that code. I'll keep it in but for reference, but I don't want to actually run it the second time. And then what I'll do is do the same thing for reciprocals. So before we actually print out the reciprocals, I think I could do with a comment saying what we're going to do. I'm so bad at typing the word reciprocal that I've actually put it in my clipboard because I kept mistyping it. So what we're going to do is create a variable called I to hold the number 1. And for as long as I is less than or equal to 10, we'll print out a message saying here we go again, the reciprocal of, I could put my first placeholder, and then I could put my second. And after the string, within the brackets, I need to put the format function and put the 2 expressions which I want to display within my string. The first one is I, and the second one is 1 divided by I, which is the reciprocal of it. And as before, I need to make sure that I go on to my next number, otherwise I'll get an infinite loop. So if I try running that as it stands, I get the output, but not very well formatted. So what I'm going to do now is to add the formatting in. And this is going to use the syntax I explained earlier. So for the first bit of it, I can just put 2 digits. But for the second part of it, the reciprocal, what I'm going to do is put a colon after that. I'm going to say I want 6 characters for it. And then I want 2 decimal places. Now I've missed out the F deliberately there. I just want to show you what happens if I do this. If I run that, I don't get 2 decimal places for every single number. It depends what the number is. I get up to 2 decimal places. So that's why I need the F in to say this is a floating point number. And then when I run the program, I get exactly the output which I was seeking. What we're going to do now is take a bit of a digression away from Visual Studio Code and from Python so you can rest your typing fingers for a short while. And we're going to look at what I would argue is the most important concept in the whole of Python, which is iterating over sequences. Let's suppose you have a shopping list. You want to buy an apple, a banana, and a pear. The important thing is you buy every single item. The order doesn't matter. You might always buy things in alphabetical order. So you might buy the apple, then the banana, and then the pear. Or you might find that the bananas are the first thing which meet your eyes. You come into the shop, and then you see the pears, and then you see the apples. Or you might buy the pear, and then the apple, and then the banana. It really doesn't matter what order you do things in, as long as you tick off every single item in your list. And that's what a sequence is. To do this in Python, use this syntax. You say, for every item in a list. The list in this context, I'll just highlight it, is the set of things which you're iterating over. And we'll discover it can be one of four main things in a moment. And the word item in this context refers to a variable which will point to each of the items in the list one by one. So in our context, the item variable will point first to the apple, then the banana, then the pear, or maybe some different order. So let's look at the properties of a sequence. It has two main characteristics. The first thing is that there should be a way to move on from each object in the list or each object in the sequence to the next item. And the second property is that once you've gone on to the final item, there should be a way to say, that's it, I've finished my sequence, I've run out of items. You can exit the loop and run the rest of the code. So what are the main sequences in Python? Well, there's four. The first one is you can have a range, which is what we're going to look at in this tutorial. A range is a sequence of numbers. You can also have a string, which is a sequence of letters or characters. You can have a list, which is a mutable sequence of things. Mutable means you can make changes to it. So the shopping list would be an example of a mutable sequence because you can add items to the list when you suddenly remember that you've forgotten to write down cherries on the list. And a tuple is an immutable sequence, so that's where you've laminated your list so you can't make any subsequent changes to it in the shop. So that's a brief look at sequences in Python. What we're now going to do is go back to Python code and show how you can use sequences to loop over ranges. So we're going to do 3 examples of ranges to illustrate the syntax, and then one full worked example. So to create the 3 syntax examples, let's create a file called rangesyntax.py. And there are 3 ways you can write the range function or the range command. You can write it with 1, 2, or 3 arguments. So let's start with the most simple one, which is with 1 argument. And what we're going to do is just print out the first 10 numbers. And the important thing is that ranges start at 0. So what I'm going to do is to create a variable to refer to the first 10 numbers. Let's call it first 10. And I'll set it equal to not a single number, but a range. And if I put the number 10 in there, what I want to do is show you that this isn't quite going to do what I want it to do. So I can now loop over the numbers in that range. So to do that, I can put the word for in to start an iterator, and then I can use any variable name I like to refer to each of the items in the sequence I'm creating. So I'm going to use I because it's nice and short and it's what I tend to use to refer to an integer. Then I can put the word in, and the thing which follows that has to be the name of some iterable sequence, or just a range in this case of numbers. So I'm going to use my variable I've created called first 10. And then I need to put a colon to say that's the end of my loop statement, and press return. So what I can now do is run any statements I like, and they will execute 10 times, once for each time around the loop. And each time around the loop, I will have a successively higher value. So I'm just going to print out the value of I, like so. And then if I run this program to look at the results of it, you'll see it actually starts with 0 and takes me up to 9. And that's because ranges always start at 0 by default. So we can get around that by using the syntax with two arguments. What I want to do now is to close down the terminal window. And to do that, if you press a Control and the inverted comma once, it takes you to the terminal window. And if you press it a second time, it closes it down. So I'll be doing that quite a bit throughout these tutorials. So let's create a second one, or second syntax example. This one is going to have two arguments. And the important learning point about this is that ranges miss out the last term, which takes a lot of getting used to. So this time I'm not going to use a variable to refer to my range of numbers. I'm just going to launch straight into my loop. So I'm going to say this time I'm going to use the variable j because I've already used I. And I'm going to put for j in, use the range function. For my first argument, I want to say my starting point, which I'm going to start at 1. And for my second argument, I'm going to put my endpoint plus 1. Because I want to go from 1 to 10, I'm having to put the number 11 in there. Otherwise, it won't include the last term 10. And what I could do within this is to print out the number, j this time. And when I run this, it will automatically display the first 10 numbers. I'm just going to comment out the lines above it so that I don't see the output cluttering it up. Then if I run my program, you can see it gives me the first 10 numbers. So that's my second way to do it with two arguments. For the third way to do it, using three arguments, the third argument is the discrepancy between each term. So at the moment it's automatically going from 1 to 2 to 3 to 4, and the difference, as you might expect it to be, is 1 each time. But it doesn't have to be. You can go up in 3 at a time, or you could even use a negative number to actually go down. And what we'll do is a couple of examples of this. One which prints out all the numbers divisible by 3, much simpler than the previous example I did, and one which counts down from 10 to 1. So to do the first one, I will create another variable, so I'll say for k this time, and what I'll do is start at 1. In fact, no, let's start at 3, otherwise it won't work. I'll go up to 100, and I'll increment my count by 3 each time around the loop. And what I'll do is print out the value of each number. I'll just again comment out my lines of code above it so they don't clutter up my output. And then when I run this program by pressing Alt-Control-N, you can see it prints out the first, 33 numbers divisible by 3. So the previous example I did turns out to be unnecessarily complicated. I said I'll do two examples. The second one, let's have another one. I'm going to use variable m because L is quite hard to read. And I'm going to print out the first 10 numbers but in the opposite order. So I'm going to start with 10, and crucially I'm going to go down to 1, but I need to put 0 in there because don't forget it will miss out the last term in the sequence. And my increment, the amount I'm going to increase each term by each time around the loop, is -1. So it's going to go negative, it's going to be a smaller number each time around the loop. And again I can print out the value of that variable. And I'll just comment out my lines of code above again. And if I now run this program, you'll see that it will print out the first 10 numbers, but in descending order. So that's the syntax of a range command. Now let's use it to actually do something, I was going to say practical, that's debatable. What we're going to do is print out the first n cubes. So to do this, I'll create a new file, and I'll call this range example. What we're going to do within this is to say for I in, range is going to go from 1 and let's go to 101. So let's print out the first 100 numbers and their cubes. So what I can do now is to print out the message I had before, which will be the cube of. I can then put my first placeholder in for my number, and then I can put my second placeholder in for its cube. I then need to put dot format at the end of that, and I need to put the two values I'm displaying. The first one is I, and the second one is I cubed. And remember, I can put star star to raise a number to the power of something else. And if I now run that program, you can see it gives me the numbers. And what I could do if I like, just to make this exactly the same as we had before, is add in some formatting. So I'll use 3 digits to display the first number, and I think I might need up to about 7 to display the second one. And if I now run that program again, you'll see it prints out the first 100 numbers and their cubes in a neat formatted way. So the range function is a much quicker and more efficient way to loop over numbers than a while loop. And it turns out you hardly ever write while loops in Python because there's nearly always a better way to do it using a for loop instead. In fact, I'll probably go further and say that if you're using lots of while loops, you probably may not have quite understood the scope for using for loops instead, but perhaps that's a bit of a bold claim. So the last thing that we're going to do in this tutorial is a more complicated case study which is going to test or list out the first n prime numbers. A prime number, of course, being one which is divisible only by itself from 1. The algorithm I'm going to use, that's a set of steps which I'm going to implement to solve the problem, is as follows. We're going to leap over all the numbers from 1 to 100, let's say. And for each of these numbers, let's call it test number, what we'll then do is make the assumption the number's prime and try to disprove it. And the way we'll try to disprove it is by leaping over all the numbers from 2 all the way up to the number itself minus 1. And for each of these numbers in the inner loop, we'll see if we have an exact divisor. And if we do, then we can flag that the number we were testing wasn't prime because we found another divisor apart from itself and 1. And we can then break out the inner loop because there's no point testing other possible divisors when we've already found 1. But if we finish that entire inner loop and the number hasn't been flagged, then it must have been prime and we can print it out. Otherwise, we'll just go on to the next number. Now, I have a few notes to make about this algorithm, 3 in fact. The first one is that it's ridiculously inefficient. For example, if you're testing 97, which is the highest prime less than 100, you only really need to test whether it's divisible by 1 up to a square root. There's no point testing any further, and there's lots of other improvements to prime number generating algorithms you can make. The second observation is that we're going to treat 2 differently to make our code clearer to read. Because 2 is such an unusual case for prime numbers, we'll just put in an if condition at the start saying if it's 2, we'll just print it out anyway. And the third and probably the most important observation is this. Often when we're training people on programming, whatever language it may be in, they try to explain what they're trying to do, and they can't actually say it in English or translate it into pseudocode, which is what I've just shown on screen. If you can't say what you're trying to do in English or in pseudocode, you've got no chance to say it in any programming language. Programming is only half about learning the language, so learning Python is only half about learning Python. The other half is about thinking of an algorithm, a set of steps which you could implement to solve the problem you're trying to solve. And with that inspiring thought, I think it's time to actually write our program in Visual Studio Code. What we'll do is create a new program, a new file, and I'll call it primenumbers.py, and then it's time to begin our loop. So we'll write a comment saying test for prime numbers, and then I'll create a variable which will hold the highest number we're going to go to. So let's call it highest, and let's go to 100. So now what I can do is begin my loop. I'll call it my outer loop, and I can say for, let's call it, as I said in my algorithm, let's call it test number, and I can say in, and my range is going to go from 2, because I certainly don't want to start at 1 and test whether that's prime, all the way up to the highest number. But I need to put the +1 in because it always stops 1 short of the maximum limit or maximum threshold for the range. So within that loop, what I'm now going to do is put an if condition to see if it's 2, because if it's 2, we're going to treat it differently. So I can say if the test number equals, don't forget I need to put 2 equal signs because I'm doing equivalence test. So if that's 2, then what I can do is print out the number. And I can either print out test number or 2, they're both the same thing in this case. And then what I need to do is make sure that I don't carry on with anything else this iteration of the loop. And the way to do that is to put the continue statement we covered earlier. And what that will do is automatically go on to test number being 3 without executing any additional statements within this loop, or within this iteration of the loop. So having done that, what I'm now going to do is to set a flag saying if prime. To do that, I'm going to call it, let's call it if prime. And I'm going to assume from the very beginning it's true. So what I'm now going to do is loop over all the numbers from 2 up to the number itself, -1, and see if any of them divide my test number. And if they do, then I'll be able to reset my flag to false, and otherwise I'll just print it out. So to do this, I can write another loop, and what I'll do is call my variable possible prime. Much of the art of programming is in giving your variables good and descriptive names, and I think possible prime is a really good name for this variable. So for each possible prime in, and what I'm going to do is create a range which begins at 2, the lowest possible divisor, and goes all the way up to the current number. Don't think I've made a mistake there by going 1 too high. Don't forget it will stop 1 short of the test number itself. So for example, if I was testing 7, that would go from 2 all the way up to 6. So for each of these possible numbers, I need to try to divide my test number by this possible prime. And you'll notice I'm writing more comments because I'm doing something more difficult to understand. So what I can do is say, if my test number, when divided by this possible prime, returns 0, then it's an exact divisor. And that means I found another divisor less than the prime itself, and so it wasn't prime. So I'll put a comment saying this wasn't prime, and I think that deserves an exclamation mark. So I can set my if prime flag to be false, and what I now need to do is to break out of this loop, because having found a divisor, there's absolutely no point in looping over all the other possible divisors, testing those. I already know it's not prime. There's no point in testing other conditions. And that's what break does. It exits the loop prematurely. So at this point, I know I've successfully tested whether this number was prime. So if it's prime, I'll print it out. And to do that, I can say if prime equals true, but in fact, because if prime is a Boolean variable, which can hold the value true or false, I actually don't need the equals true. The thing which follows the if statement has to be any condition which is true or false, and if prime, it satisfies that. So if it's prime, then what I'll do is print out the value of my variable, which is test number. Because I'm always wary about infinite loops, even though I don't think I can possibly get one, in this case, I'll just put a little statement saying that's it. Let's see if this works. I can run my program as usual, and astonishingly, and this unusually for any program, I have to say, it seems to work first time, including printing out that's it at the end. And what I could do then is have a bit of fun by seeing how quick my computer is. So if I go, instead of going to 100, if I go to 10,000 and run the program, let's see how quickly this runs. And if I run that, then I should be able to see that it's printed out the first all the prime numbers up to 10,000. And that ends this tutorial on formatting, ranges, and iterators.